Hey, hello friends. I would like to share this project. This is a Class AB audio amplifier from DIY.com. And the weird thing about this amplifier, I do not see that it's well promoted. I don't think that they don't want to promote this amplifier. I'm not sure why they do not share these files. Okay, what I can share is only the PDF file, so you can etch it at home, but I cannot give you the file or sprint file because this amplifier design they sell this PCB. The original PCB is sold by DIY.com, so I cannot give you the Gerbers or either the sprint file. So the only thing I can share is the PDF file, and this is a great amplifier. Last year I was trying to simulate the circuit using the multisim 14. I was not able to simulate successfully, so I just dusted out the files that I found on one of my hard drivers. So I decided to take a look and to see what was wrong with the circuit. So I found out that I misplaced some connections on the simulation. I do have it right here. This is the simulation of this particular amplifier, the Honey Badger. Now it's 2016, so I tried last year, but it was not working correctly. So right now I have it working correctly. There is some weird thing that happened on the simulation because this is only a software simulation. It's not gonna simulate everything that the amplifier is doing right now. So keep in mind this is just a simulation. It might be different in a real time. So successfully I was able to simulate it, and I have from one sample. This amplifier is more for to listen to nice music, not to high power units. It's capable of giving about 150 watts and even more, depending on the transformer that you have. You have a 500 VA volt amps transformer. It will supply plenty of power for your needs. But this is more like for home use, to listen to soft music and stuff like that, like jazz and stuff like that. It was designed by Mr. Pete Ostripper, but some members of the DIY.com, in conjunction with working together with Mr. Pete, they from the ground up, they create this design. So I do have the original files. I want you to show you. I want to show you the original file before I show you my clone, PCB clone of the. This is the link. Sorry about that. This is the link where where you can download the file so you can etch it at home. So let me explain you later about that. So this video might be a little bit longer. Sorry about that. So these are the files. This is the compressed file that you will have all the data of this amplifier so you can etch it at home. So I have two folders. With option 1 is this is a way that you can install it with the L bracket adapter. This is a piece of aluminum, so you can install it in the. For me, it's more easy. It's easier to install in this way than the other way, because you will have the aluminum L-shaped adapters. So for me, it's a lot easier. Sorry about. I'm trying to. Okay, so this is the black and white PDF file. So you can I place those black pads, so you can drill for the screws, so you can attach the transistor securely into the aluminum piece of aluminum. I have the image of what I mean, so you can install the transistor on this piece of aluminum so to secure them, and then you will screw this to the larger heatsink. uh, this is what I have in mind. So alright, okay, also I have on the same folder as folder option 2 is basically the original layout, so you without that L-shape adapter. So you can install it closer to the heatsink. So you can see I have the files here. Let me see, I gotta close this. Component mirror version. Okay, on option 2, you will have the component guide, component mirror. You will have the original version for the UV. I misspelled this, Night UV night. It's supposed to be light, UV light etching. Sorry about that. And you will have the original file. As you can see, you can etch it without that portion of the PCB for the L-shape adapter. So this, let me see. From this simulation, the amplitude, the voltage, it should be like at least 56 volts. It was recommended to have a 40 volt AC output transformer. So that will be, okay, one sample, 40 times 1.4142. It will give you about 56 volt DC. It might go higher a little bit, just maybe 5% more, depending on the capacitor, but it's about 56 volts, so it should be fine. So on the simulation I have 60 volt DC, but it's supposed to be 56, so it's fine. It's just fine. It's just for the simulation. So it responds really well. The slew rate is pretty fast, I noticed that. So you can see here the sine wave of the amplifier. I'm feeding with an amplifier with 1 kilohertz sine wave, 700 millivolts amplitude. So right now I'm going to activate the simulation. You can see it's a pretty fast slew rate. Right now the output right now is 193 watts, 0.03 sorry about that, 0.003%. That's pretty good. So it's a pretty fast slew rate on this design. Now I have let's talk about the components and the initial bias adjustment. There is instructions here in English, of course. These are from the original website, DIY.com. Here are all the instructions in English, so you can read it. You can follow all these instructions. So one thing that I noticed that is really important. I asked Mr. Pete one time, like last year. I asked him how I can initiate the PCB, I mean the amplifier. So he told me do not install R36. So this resistor, at the moment of the first turn on, do not install R36 until you will set the bias correctly. First of all, before you turn on the amplifier, you gotta set the CCS according to the instructions. It says from 70 ohms to 100 ohms. So that will be located right here on the, let me see, I gotta show you that. It's located here, the CCS adjustment. That's let me see if, okay, CCS. All right, let me see if I can find it. The adjustment. Okay, the options here are numerous. The small CCS adjust has a 20 turn, a 200 ohm trimmer R7. This CCS control the LTP current. It can be adjusted between 1.8 milliamps to almost 6 milliamps. Optimum is 70 ohms to 100 ohms. So on R7, so giving 3.5 milliamps at the tail of the LTP. The big CCS is part of the VAS with R27 equals 68 R. So on my PCB, I decided to change R27. As you can see, I place a, something like a marking on R27, so I choose 68R. So that's the option that I choose. Okay, on the trim pad, it's supposed to be a 500 ohm trim pad, but I will guess that it will be more safe to use a 1K trim pad and then adjust it to about 600 ohm or 550 ohm before you adjust the bias, before you do the bias adjustment. I will suggest to use 1K instead of a 500 ohms. That's my opinion. Maybe it's not gonna be. As you can see, when I highlighted the trim pad, it will show all the trim pads on the circuit. So this one is simple. The only thing you gotta do is just place a multimeter from the middle pad to this pad over here. So this pad over here. So this one here, and you adjust that to 70 ohms or 100 ohms. So that's the first adjustment. This trim pad, you will adjust it to about, like I say, this is a 1K trim pad, so you will adjust it to about 550 ohms or probably 600 ohms, just to be sure that you're not going to blow up the power transistor. So I would actually suggest a 1K right here on the R30, the bias. In Spanish we call it bias, but it's bias. So alright, so let's continue with the offset. For now, according to the instructions, you will set this to have to read the same measurements from one pad to the other. One sample from the middle pad to the top pad, you will adjust it. One sample, this is a 1K, so I will guess it's like a 500 ohms each. So it will be 500, probably 500 ohms each. So from here to here 500, and from here to here 500. So half of the, or just center that trim pad. Alright, so I hope you guys can understand me. Okay, now we're going to talk about the transistor, the signal transistor. I found out that some transistors, they are not available anymore. It's basically this one here. I was searching online for this particular transistor, and it's not available anymore, but you can use a on the same folder I place all the data of the power transistors. So I think that is one on here, this folder. Okay, let me see. This one here is not available anymore. The one that is available is this one here, KSA 1381 is available to purchase on Mouser. So right now, if you go to Mouser, you will found it here on Mouser. This is the transistor. It's not that expensive. At least it's 44 cents PMP. 300 volt. Okay, half amp, 150 megahertz. So this is the transistor. So the other one is not available anymore. So don't worry about this one. Not to find this one here. So Q10, you can use that one right there, the one that I just showed you a few minutes ago. Okay, let's talk about so we talked about already about the adjustment of the trim pad. This is the Baker clamp diode. I do not use it on my the PCB that I ordered last year. I did not use that. These options I'm not using. So if you want to use it, but I would suggest not to use it, because I don't think it's needed. In my opinion. So I do have the pictures of the PCB that I ordered. So I think I skipped that option. As you can see, the Baker clamp, I did not use that option. So you don't have to worry about that. Okay, one important thing, I choose to use the center diode here. As you can see, there is a center diode. You can use a 12 volt or 15 volt center diode, and then do not forget to set the jumpers. So you will place a piece of wire, as you can see, from C to Z. So you will place that wire. As you can see, I do have it on the illustration of the PCB. So it's this one here. This is the piece of wire from C to Z. So do not forget to install that wire if you are to choose the center diode. I think I already placed the information here. Use center diode here, 12 volt or 15 volt center diode. So it's already illustrated right there. Okay. What else I gotta talk about it? Oh, here you will have about the capacitor options. You can have the pitch distance or lead space between the leads of the pads. Sorry about that, the pads. You can use a 5mm pitch distance, or you can use a 7.5 millimeters on these larger capacitors. On this one is 5mm, on the bottom one too is 5mm. Okay, on this capacitor in particular, it has two size. You can use 3.5 millimeters, or you can use 5 millimeters. So that's why I have this one have. Did I say that right? Have 3 pads. All right, 3 pads. Has. Did I? Okay, let me know if has is the correct word. I'm not sure. Has 3 pads. Did I say that right? Okay. This one here is 3.5, and the other one from the other one is 5. What the hell? Okay, 5 millimeters. Sorry, we had two sizes of capacitors. So here, this one non-polarity capacitor. This one here is 5 millimeters, and this one is the input capacitor. For the first input capacitor, this one will have 5 millimeters. From here to here, you can have 10 millimeters, 50 millimeters, 20 millimeters, 22.5 millimeters, 25 millimeters, or up to 30 millimeters. So you can place a really large capacitor if you want to. So you will have plenty of options. So this one here is an idea that I have to use RCA input. So this one here, you can find this particular part on DigiKey. I purchased a few of them. So let me see if I can find them on DigiKey. That RCA. Okay, right here, RCA. So this is the component that I purchased. But I have one idea. You can purchase the red one. As you can see, you can purchase the red one as a right channel and the white one as a left channel. So that's also a good idea. So to identify the channel that you have. So I will purchase the red one for right channel and the white one for the left channel. Let me see on the images. I'm not sure if on the images it will show the. Let me see. I cannot show. There you go. I think this one here is red. So this is the red channel. The other PCB that I have is the white one. So it's the left channel of the audio amplifier. Oh yeah, about the coil, really important. On this PCB, I think I made a mistake on the coil. I should choose a thicker wire. This one here is 18 AWG, a standard measurement from the USA, I think it is. So I should choose a 15 AWG. It's a thicker wire. The diameter of this one here, I use you know those. Let me show you. Right quick. Container 50. DVDs container. Let me see if I can show you that. All right. So, okay, I have the idea. You know this the middle pole. I just cut the pole and I use this as a reference to create the coil. So I drill one side of this plastic pole to keep the wire from spinning. So I use it to create the coil. So this is what I use to create the coil. So it might be a little bit ridiculous, but it works for me. So it did work for me. So pretty well. So that's the way. That's how I made the coil. What else? The jumpers. Yeah, really important about the jumpers. Make sure you have all the jumpers. Do not forget about the jumpers. Right now here you will see the jumper one. Okay, let's do this. I'm going to select the jumpers to create a build group. So it will illustrate where are the jumper illustrated. So build a group. So it's a lot easier to do this. It's a lot easier to do this, my friend. Oh, okay. I got one that I forgot here. This is a jumper too. All right. So jumper. Oh, this is a jumper. This is the one that I use. Jumper, build group. All right. Build group, jumper. All right. Let me see how many jumpers we have here. Okay. Here we got more jumpers. Okay, there you go. All right. Build group. I'm just highlighting the jumper so you guys can see where are located. So you gotta make sure you place those jumpers. They are really important. Do not forget about those jumpers. Okay, there's one more here. Jumper. There you go. Jumper. All right. Let me see how many we have. So I'm guessing. Okay, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I hope I have all of them. Let me see. I gotta make sure. All right. I gotta make sure. Yeah, it's about 17. Yeah, 17 jumpers. So do not forget about the wire jumper. I'm suggesting that this one here, since let me do a quick test for this jumper here. You can see this one here. It needs to have a thicker wire jumper. You can use you know those enameled wire. You can use a thicker wire, like at least 1 millimeter, so the current can travel better from this wire. This one in particular, this one here in particular, the one that I mean showing you. Oh my god, it's so difficult to. Oh my god, because I make video, most of my videos I make them in Spanish. So all right, so also this one here is really important. This jumper use a thicker wire for this one here because it's gonna supply current for the positive for this area. Right now this one here is the positive, so let me use test. So it will supply a current. I see that. What is doing that? It's not. Oh, okay, I see why, because I select. Yeah, I see why it's doing that, because I build the group, split the group. So let me separate this just to make sure. Oh, let me see one more time. So gotta make sure this, so you guys don't get confused. Let's do it the same thing again. Okay, if I make a test here, I think it does make sense, because there is a jumper from here to here. Let's see. Oh, it's still doing the same thing. Okay, let me see. Let me see. Alright, let me see. I gotta make sure that this is correct. Alright, let me see. Split the group. Split the group. Man, I got like 1,000. There you go. Split the group. Split the group. Alright, there you go. Let me see. One more time. Still doing the same. Yeah, it makes sense. It does make sense, because there is one jumper from this this wire right here. Let me see. Weird, huh? It's weird. Let me see. Wanna place the test. Oh yeah, I forgot. Sorry about that, guys. Don't get confused. Sorry, I forgot that this PCB is a double layer, so that's why it's doing that, because I have a double layer on this PCB. I forgot. I totally forgot about it. So this is a double layer PCB. That's why it's doing that. Right now, if I make a test, it's going to show you what traces are connected to. So that's why it's doing that. So okay, don't worry about that. So it should be fine. It should be fine. Don't worry about that, because this one here is double layer, so that's why it's doing that. I was a little worried for a moment, so that's why it's doing that. Kind of weird. It showed that like this one is connected to this one here. It's kind of weird. Not supposed to be doing that, but this one is on top of this. That's weird. It is weird, because if I remove the C1, it's not going to affect anything. So it should be fine, because it's not going to affect anything, because this is a single layer PCB right now. So that's why I made the wait, hold on. That's why I made the PDF files. So right now I made a PDF file, so it should have no problem at all whatsoever. As you can see, I wonder if I eliminate all the copper, as you can see, there is no, it should have no problem at all, because it's all separate. As you can see, the output, this trace here is the output, so it should have no problem. So it's fine, it's fine. I'm just a little picky, sorry about that. I'm just a little bit picky about this. So yeah, I like to make sure I have everything correct. So on the 3D file that I have here, I also can check for connections here. So let me see. I just gotta make sure that I have this correct. There you go. It's fine. It's completely fine. As you can see, this is the output, and this connection here is the negative feedback. So yeah, this one is a really important trace. That is correct. So it should have no problem at all here. There you go. That's the output of the driver. En Spanish we call it impulsores. No sé por qué le dicen impulsores. I don't know why they call it impulsores, but anyway. So here's another output. You can see here. This is the positive trace. You can see. This one here is the negative trace. I mean the ground. Sorry about that. This is the negative from the power supply. As you can see, supply voltage. So all the power transistors and driver transistor. Output, like I say, the output. Let me see. This is the positive. All good to go. Yep, good to go. And this is the coil. The output is this one here. This is the output of the power amplifier. So it's illustrated right here. This is the output of the power supply. I mean, the output of the amplifier. Thinking about power supply. Oh my god. All right. One more thing about it. There is some transistor that you need to match that are really important, like Q1. I think it's Q1 and Q2. Let me see. Gotta make sure. These two transistors, you gotta match them. Q1 and Q2. That's why you see a zip tie. Sorry about that, zip trap. What the hell? Zip tie. You have a zip tie to attach them, to secure them together, because they need to. I just place a little bit of thermal paste, so they share the same temperature, so they will be matching the temperature, so they will be equal. So that's really important. And let me see the other one. I think the other two transistors that I did the same thing. These two transistors, you gotta do the same thing. You gotta match them. You gotta put just a little bit of thermal paste, and then you use a zip tie to attach them, to make them together. Oh, I should use this option. I'm not sure if I can fix it right now. Probably I cannot do it right now because they already installed it on the PCB. But I did that with the honey badger. I mean the honey badger. God the hell! Stop talking about the Wolverine. Jesus Christ! I got a lot of stuff in my mind, man. This is difficult to do. All right, let me see. I did the same thing with the Wolverine PCB that I did last year. I think this is the video. Okay, hola amigo, quise hacer un video. Okay, so this is the one that I made. As you can see, I use you know the shrinking tubing. This is the best option to choose for this particular matching thing. They need to share the same temperatures. It's a lot better. What I did, I just used the stove. I placed those matching transistors. I put them together with a little bit of thermal paste, and then I use shrinking tubing. I use the stove. I turn on the stove. I place the transistor not too close to the flames. I don't want to destroy the transistor. So, and they shrink them, and they were really tight together. So, yeah, I think I have the pictures of this. I'm not sure where I should have the pictures. I don't know where I played those pictures. The Wolverine. Let me see if I can remember. Alright, don't mind about that. So that's the idea that I have of installing those. I think for my next, if I order this PCB one more time, of course this is only for personal use. Do not think that I'm going to use this to sell. So So that's the important thing. I should place a piece of copper top here to reinforce this fasten connector. I forgot to do that. So I should have yeah, why I didn't do that, man? Oh my god, I forgot to do that. I can just copy this and place it C1 on top of the, so you will have a reinforced. I cannot do that. I remember why not. Yeah. I remember now. I cannot do that because it's gonna yeah. Oh wait, hold on. Give me a minute. God damn it. Give me a minute. Sorry about that. I know what I can do. Yeah. Let me see. Okay, this is okay. I can just place it right here. Yep. All right. Don't mind about that. This is some only ideas that I have. Let's see about the initial bias. I think you guys should follow Mr. Pete instructions of installing this resistor, 68 ohm resistor, on the emitter of this driver transistor Q15 and Q14 to the output of this coil right here. You can see the illustration. So that's one way to do it. So I should follow what he says. So you will install a resistor from here, from this pad, to the output, to R46 output. One example, you will place one sample. I'm just gonna place a line as a resistor, so you guys can see one resistor like this. This is the resistor. This is just an example. So you will place one resistor from this spot to this spot, and the same thing you will do to the other transistor from this emitter to the output coil. Okay, it's this one here, the output coil. So wait, hold on. I choose the test. There you go. Oh, what the hell is doing the same thing? It's doing the same thing. All right, so this thing got me worried about a little bit. Let me see. It got me worried for real, man. I'm just, my mind is so complicated. Let me see. I gotta make sure. This is what I have here. As you can see, I don't think it's a big deal. I mean, in my case, because this is my double layer. So in your file should be fine. Should have no problem, because this is only a single layer. You should have no problem with this. So you guys should be fine. You can see there is no double layer on this PCB. It's just a single layer. Well, let me see what else I can say about it. I talk about the bias. He mentioned that you can use the safety resistor to do the first initial testing, or you can use a 210 ohm resistor, 1/4 watt or half watt. You will use it as fuses, so to test the amplifier for the first time using. I think I should use a lower voltage to test it out first. One sample 35 volt DC or probably 40 volt DC, just to test it out first with a live bulb to make sure everything is fine, so it will not destroy the output transistor. But no, it's not gonna be destroyed because you don't have this. I gotta mention that you don't have this resistor installed on the PCB. So you will be safe if you follow the instructions of Mr. Pete that are right here. Here are all the instructions to follow about the initial test on this amplifier, and even more options here. So, oh my god, oh, this is really important here. Alright guys, I'm gonna cut the video. I'm gonna make this one in Spanish for you, for the Spanish, for my Spanish friends from Venezuela, Bolivia, Costa Rica, Cuba, Puerto Rico, you know, everything, all Latin people, Mexico, Mexico. No sé. Alright guys, have a good day. I made this video way too long. Alright guys, have a good day. I will upload the files. I mean, I already did it. Sorry about that. I already make a link so you can download the files. These are the links, so you can download all the files on the description down below of this video, so you can take advantage of making this really nice audio amplifier. All right guys, have a good day, and you know, keep practicing electronics. All right.